Hello, and welcome to today's session. As always, I'm your host, Kevin Grote, Senior Engineer and Technical Partner Manager here at VMware. Today, we've got a very interesting session. We're going to be talking about a solution concept. Today, what we're going to be talking about is portability, capacity, all of the decisions that have to be made when we're talking about those solutions. We're going to be bringing in our focus today into vSphere 6, talking about things like long-distance vMotion, SMP Fault Tolerance, as well as discussing some of the plays and considerations have to be made when we're talking about capacity for those. So with that, let's get started. Long-distance vMotion is a brand new concept inside of vSphere 6. Now, what makes it so unique and so different is the way we're doing it. Now, customers before have done vMotion over relatively long distances with things like metro-based storage. But with this, it's significantly different because we're talking about the ability to use VMFS data stores, NFS data stores. It's a shared nothing transfer of the machine. It does not require vVols, but if you want to use it, that's great. If you want more information on virtual volumes, be sure to check out some of the other sessions. It is active only, so it will support either synchronous or asynchronous replication. Now, what are some use cases, some reasons that you would do this? Well, permanent migration would be an easy one. You've got machines over in site A that need to get over into site B. Pretty simple. Or perhaps you're looking at disaster avoidance, right? Chicken Little, the sky is falling. We need to get these machines over from site A to site B as fast as possible so that we can avoid having to declare a disaster. Perfect for long distance vMotion. Another one is multi-site load balancing, or what you would consider like a follow the sun type approach. So maybe you have a customer who moves their workloads from offshore to New York to Los Angeles and then on further as the day progresses so that they're always having optimal resource allocation. These are the types of things that are possible when we're talking about long distance vMotion. So what are some of the specifics? Now, we give you up to a 150 millisecond round trip time. So what that means is that when the vMotion check occurs, that you're going to have up to 150 milliseconds of latency that will be tolerated for vMotion to work. Okay, that's a lot higher than it used to be. It used to only be 10 milliseconds. So this is a significant, massive change upward. Also, you're looking at, as of last publishing, 250 megabits per second as the bandwidth requirement between those 2 points. So as long as you fit all those parameters, long distance vMotion is going to be a great play for you. Now, if we're moving machines from point to point, then it makes sense that we're going to need to make other enhancements to vMotion. Cross-switch vMotion is another biggie. Basically, this means that you can now migrate a virtual machine that's living on virtual standard switch A to virtual standard switch B. Before, that would break vMotion. But now, machines are capable of doing this. And you can go from standard to standard, you can go from standard to distributed, you can even go from distributed to distributed without losing the metadata. So all of the stuff like throttling, failover, traffic shaping, that's all going to stay when that machine moves. So that's really important too. You don't have to recreate the wheel every time the machine gets moved around. Also, again, think about long distance vMotion, all the stuff we're talking about, right? This idea of stretching out. Now, the one thing you can't do is you can't go from distributed down to standard, simply because it would strip too much information off. So as long as you're going one of these three ways, standard to standard, standard to distributed, or distributed, distributed, so basically equal or higher all the time, then you should be good to go. We can also do cross vCenter vMotion. again, let's loop back to these ideas. We're moving machines around lots of different places. So what does cross vCenter vMotion allow us to do? Well, exactly what it says. It allows us to take machines that live inside of vCenter A and push them off, whether through short range vMotion or long distance vMotion, whatever it is, and move them into being managed by another vCenter. So when we're talking about real collaboration in enterprises between IT infrastructure administrators, this is where the magic starts to happen, because now they're able to share, collaboratively manage resources, and because of the cross-switch vMotion, perhaps they have slightly different rules or slightly different naming conventions or whatever it is, they're going to be able to leverage that as the machine moves to and fro. So this brings us back to those fundamental concepts of expanding the vision of what's possible within current investments, leveraging the further ecosystem, and allowing administration more flexibility in the decisions that it makes. So some more vMotion-y goodness, some other things that have happened inside of this idea of portability when we're looking at vSphere 6. Like I said, cross-center vMotion, being able to move machines from one vCenter and data center over to another vCenter and virtual data center. That's big. Another one is the support now, full support, for vMotion of Microsoft Cluster virtual machines. See, Microsoft Cluster virtual machines usually require that they have what's called an RDM, or raw device map, basically a drive that's not one of the virtual machines files. And that's there to optimize, scale the way the Microsoft Cluster works, but we couldn't vMotion those effectively. Well, now if you've got a machine that has a raw device map, as long as it's in physical compatibility mode, you're going to be able to move that machine from one host to another. It also means that it's going to be able to benefit from all of the things that happened with vMotion, whether you're talking about high availability, distributed resource scheduling, all of that. That's all going to come looped back, and now it's accessible across even more workloads. So now let's talk about fault tolerance. So fault tolerance has really changed. Before, we could do fault tolerance for a virtual machine that only had one virtual CPU. Now we can do it for a machine that has up to 4 virtual CPUs. Now, this is something that needs to be treated with, I guess, the respect that it needs for the power that it has. Let me give you a case scenario of what this means. So this is going to be for your very important or very specific workloads. Now, my family considers me, I hope, to be a 0.0 recovery time objective type of workload. They need me here. I am a mission critical work source. Now, because of that, let's say a doctor came up to me and he said, you know what, Kevin, we can get you a clone. And what that clone can do is it's going to know everything you do. It's going to dress the same way you do. It's going to tell the same terrible jokes that you tell, eat the same food, like the same things, all exactly like you. What's the catch? Well, Kevin, what you're going to need to do is you're going to need to build a room on the side of your house. And in that room, you're going to need to house your clone so that the clone can learn, that it can eat. And you're going to have to buy it clothes. And you're going to have to buy it food. And you're going to have to tell it the same stupid jokes. All of this stuff so that it can be just like you. That way, if something should ever happen to you, then your clone will walk right through the door and your family won't know the difference. Okay, so what do we know about this scenario? 1, this is going to cost me. Number 2, it's going to be really cool. But I need to treat this decision with the respect that it deserves. The same is true when we're talking about symmetrical multiprocessing for fault tolerance. Best practice always says you give a virtual machine 1 virtual CPU. And it's still true. Not every virtual machine needs multiple CPUs. But when we're talking about workloads, things like Oracle databases, things like cloud provisioning workloads, then we might need to leverage multiple virtual processors. And in those cases, now we can protect those with fault tolerance. So the moral of the story is, it's not for everything, but when it's right, it's right. And it's one of those features we need to keep communication lines open with our customers so that you understand when to use it inside of your architectural concepts. So in addition to fault tolerance, another thing that we've done is we now have fault tolerant storage. So basically there's going to be a shadow copy made so that even the storage of the machinery is going to be fault tolerant. This is another step forward in what we're doing inside of the ideas of recoverability, portability. Now, one question that comes up all the time. With Heartbeat no longer in play, what are the options for protecting vCenter? Can I use SMP Fault Tolerance? Well, the answer is you could. But here are some of the options that you could look at if you're talking about protecting your vCenter. Could be anything from HA, could be just backup, maybe vSphere data protection, which is now included. It could be SMP Fault Tolerance. That would cover you for a hardware failure. You got to remember that's only going to be relevant to smaller sizes where you're only using 4 virtual CPUs for a vCenter server. Or you could also use Windows Server failover clustering. Now we have support for Microsoft clustering services with vMotion, so you could fold that in there as well. So there's lots of options, lots of different ways, again, depending upon the architectural requirement of how you can protect your vCenter. With that, let's go ahead and take a look now at a demonstration of how to think about capacity and how capacity relates to the ideas of portability. After all, if we're going to be moving machines to and fro, we need to make sure that we have the capacity to do so and that we're aligning our infrastructure so that we have the capacity to make these choices. We also have another demonstration for you to explain more about how capacity is calculated inside of this space. With that, let's keep going.
So when we're talking about these ideas of machine portability and what we're going to do from an architectural perspective, we can't negate the fact that we have to have some cognition around our current environment. VRealize Operations gives us a great lead into this. With a screen like the one we see here, we can pretty clearly see that we're looking at an environment with very little to no issues. However, that doesn't necessarily mean that we're free to just completely let things off the chain and consume at will. Talking about these ideas of vMotion, high availability, fault tolerance, we need to consider what the rest of the environment looks like. In very short order with operations, we'd be able to drop in and take a look at this environment at a high level and get some amount of perspective into the types of capacity concerns that we might have. So where we had an environment that at the onset looked very, very solid, we can see that we have issues with memory allocation and consumption inside of this environment. We can dig down deeper to find out even more. For example, this particular host, we can see has almost 23% of its remaining capacity left, including buffers for things like high availability. And it also gives us some scope into the types of machinery we could still drop in here based upon the types of machinery it sees us create. However, to the contrary, this other host doesn't have nearly the capacity. This means that if we were to start to put in place ideas around fault tolerance, or we were wanting to increase percentages for high availability or admission control, we need to take this information into account. This is why when we look at an overall holistic approach to the virtual data center, including things like vSOM, or vSphere with Operations Management, and VRealize Operations, is paramount to the success of having a truly thriving virtual data center. We'll look at more demonstrations around VRealize Operations in other enablement, but let's take this for today and connect back this idea into the concepts that we're talking about with portability and capacity.
Businesses need a capacity management solution that empowers IT administrators to become more agile and adaptable in responding to resource demand and supply fluctuations. IT also needs to have comprehensive visibility into current capacity to better forecast future capacity of the different object types. VMware VRealize Operations Manager helps you apply demand and allocation capacity planning principles while managing the capacity of your virtual and cloud environments across any object type. Let's examine this using a virtual machine. Allocation is the total amount of a resource you configure to the VM. Demand is the amount of that resource the VM is presently asking for, and usage is the amount of that resource the VM currently receives. When demand is higher than usage, the difference between the two is resource contention, something that can negatively impact application and workload performance, especially as contention continues to build. If your environment can accommodate X number of VMs, and you're only running a smaller number than X, then you have room to grow. You may also have chosen to have extra capacity to accommodate failover or other possible scenarios relevant to your environment. Either way, having this clear visibility into capacity is critical. When usage is higher than demand, there are opportunities to reclaim capacity if you choose to. This translates to idle VMs, powered off VMs, or VMs that need to be right-sized. For example, let's take a cluster that has been allocated 16 gigabytes of RAM. This cluster's workloads are currently demanding 11 gigs to meet OS and application resource needs, but they're receiving only 8 gigs, clearly not enough to meet their current requests. So the difference between demand and usage, which is 3 gigs, is resource contention. VRealize Operations Manager provides the capability to use both allocation-based and demand-based capacity models. For a production group of workloads, you can use the allocation model to assess capacity risk. You wouldn't want to overcommit resources because you want to manage for performance. For example, in your production environment, you may not want to overcommit memory and possibly have a low CPU overcommitment ratio to ensure that your environment is performing well. For a test group of workloads, you can use the demand model to assess capacity risk. You wouldn't care how much you overcommit because you want to manage for higher density. For example, in your test environment, you may be willing to overcommit heavily to get as many workloads as possible, as long as the environment can continue to run adequately. Using both methods together gives you a clear picture of how much resources your workloads demand, how much of your total physical resources are allocated, and if you are over-allocated, and by how much. The great thing is that VRealize Operations Manager allows you to leverage both of these capacity models in policies that you assign to groups of objects. You can manage the environment for performance, or for higher density and utilization, or both. This deep understanding of demand and allocation requirements will help you gain a more actionable view of immediate and future capacity needs. That way, you can execute capacity changes and purchase hardware or virtual infrastructure on a timely basis. With the agility and flexibility in VRealize Operations Manager, you can now optimize and forecast resource capacity and meet even the most complex business needs and requirements. To learn more about the capabilities of VMware VRealize Operations Manager, visit vmware.com/go/VROps.
So if we take a look at all that we've just saw, we've talked about long distance vMotion, we've talked about symmetrical multiprocessor fault tolerance, we talked about the idea of having a personal clone, which was pretty cool, and all of that wrapped up in the idea of machine portability and where we're going with vSphere 6. And we also closed the loop to talk about capacity and capacity management. After all, as we saw in the demonstration, just because all the lights are green doesn't mean that we have an environment that we can just consume at will. And we also saw a little bit more into how operations deals with the ideas of capacity and how we as technicians can deal with the ideas of capacity. So if you have your capacity aligned, you have the capabilities brought to you with vSphere 6 and new ideas of portability, then you're going to have a very versatile, very adaptable, and very resilient environment. I want to thank you very much for taking time to join today. As always, I hope you found this information helpful, and I'll be looking forward to talking to you again real soon.